Hello students. Now we will be discussing the second type of Zeeman effect, the anomalous Zeeman effect. Anomalous Zeeman effect is the splitting of spectral lines of atoms having non-zero spin angular momentum. Okay, it is the splitting of spectral lines having non-zero spin angular momentum in a weak magnetic field. Such a splitting is called anomalous Zeeman effect. Now consider an atom specified by a orbital angular momentum capital N, spin angular momentum S and total angular momentum J. In the absence of the field, its energy is E0, which is 2J plus 1 fold degenerate. Now when we place this atom in a magnetic field, it has an interaction energy delta E is equal to minus mu dot B. Okay, mu is the combined form of magnetic moment will be of angular momentum, orbital angular momentum magnetic moment plus spin angular momentum magnetic moment, right? So, you know the equations of mu L and mu S we substitute as E minus E by 2m into L plus 2S dot B. Okay. Now, when the field is weak, we know that LS coupling will be prominent. Okay, and we cannot break J. So, J will be in the combined form, we cannot break it as L and S. Therefore, L plus 2S can be assumed to be equal to G times J, where G is a constant called the Landé G factor. Right? Now, find out what is J dot L plus 2S. That is equal to J square. So, J dot L plus 2S is equal to J dot L plus S. Okay. Since L plus S is J, you can write it as equal to J square plus J dot S. Okay. Now, what is L? L is equal to J minus S. So, what is L square? L square will be equal to J square plus S square minus 2J dot S. From that, what is J dot S equal to? J dot S equal to J square plus S square minus L square by 2. So, we get the value of J dot S. Now, therefore, J square plus J dot S is equal to J square plus S square minus L square by 2. This is equal to J square. Okay. Now, when we expand this J square, we know that it is J into J plus 1 H square plus J square is J into J plus 1 plus S into S plus 1 minus L into L plus 1 by 2 into H square, that is equal to G into J into J plus 1 H square. From this equation, we get G is equal to Landé G factor, small g is equal to 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 by 2 into J into J plus 1. This is the equation for Landé G factor. So, we know that G is dependent on J, S and L. Therefore, the interaction energy delta E is equal to E by 2m J dot B. So, what is J dot B? That is JB cos theta. We know that J cos theta is the space quantization factor. It is equal to JZ H cross. Substitute it as JZ H cross. We get E by 2m G B MJ H cross. So, JZ, the value of JZ is MJ H cross. So, that is equal to delta E is equal to MJ into mu B. What is mu B? E H cross by 2m. Okay. So, that is substituted as mu B, G into B. So, interaction energy mu E delta E is equal to MJ mu B, which is a constant, and it's also depending on another factor, Landé G factor, G into B. Now, during splitting, each energy level depends on N, Mj and G. So, from the equation, we find each energy level depends on N, Mj and G. Therefore, total energy E is equal to E0 plus Mj B G mu B, where Mj has 2J plus 1. splitted levels. Now, what are the possible spectral transitions? These allowed transitions are delta L is equal to plus or minus 1, delta S equal to 0 and delta Mj is equal to 0 or plus or minus 1. Using these transition, what is the value of the frequency of the emitted spectral line? So we take the initial level as Ei is equal to E0i plus mu Bb Gi Mji and Ef, the final level Ef is equal to E0f plus mu Bb Gf Mjf. Okay. Now nu is equal to Ei minus Ef by h, that is equal to nu 0, which is the original unsplitted frequency, mu 0 plus mu Bb by h into Gi Mji minus Gf Mjf. So these are the fractal the frequencies which will be emitted during the anomalous Zeeman effect. So this anomalous Zeeman effect is a direct consequence of electrons' spin.